Okay, this is activity 3 from lesson 7. So activity 3 is calculate the slope. And as we go through this activity, we're going to move from the language that we have been using. So I've been referring to the slope triangle, and I've been talking about units of y along the vertical direction and units of x in the horizontal direction. And the comparison of those two values is the slope. But now we're going to move towards a more common language of both describing the slope and calculating the slope, and that is using the word change. And so these units along the slope triangle in the vertical direction is called the change in y, or the vertical change. And then along the horizontal direction is the change in x, or the horizontal change. And once you do that, you no longer have to make the point that you're referring to the slope triangle. And we'll get there in a little while. Now, we have been using the word change. When we talk about rate of change, we've been talking about the change in y. So how much does y change for each unit of x? So you go over 1 unit of x, how much did y change? In this case, you go over 1 unit of x, I think y changed 2 units, if this is 1 right here. So we have been using the word change as the rate of change. So now we're going to expand the use of that word to the change, the vertical change and the horizontal change. All right, so the number of units along the vertical axis here, the number of units of y is equal to 6 units. Right here, that's 6 units. And how do you calculate that? Well, you have 3 units that you've moved up, and then you start counting at this point. So this is where the triangle is, or the points that you're looking at, or the point that you're using is. And then so you count up 3 units to get to there, and then you count up another 6 units to get to where this point is. So that is equal to 9 units, this 9 units, minus this 3 units. So you take these 3 units away, and that's equal to the 6 units. So this is the change in y. So how much is this y changing from here to here as you move from this point to this point? Well, it changes by 6 units. And how do you know that? Because you take the 9 where you end up with, and you subtract the 3 where you started with. So that change is 6 units. It's 9 minus that 3. In the horizontal direction, this length along the horizontal side of the slope triangle is 3 units. So this length right here is 3 units, even though it goes out to this coordinate, which is 4. So there's this 1 unit. So there's 1 unit to start with, and then when you get to this line, then you count another 3 units to get to the end here. So what is that change? So it's this 4 minus this 1. If I started here and I moved 3 units to the right, that change is those 3, or are those 3 units. Well, how do you calculate that? That's the 4 where you end up with. And it's the same up here, by the way. This 4 is the same as this 4. So it's the 4 where you end up with, and you subtract the beginning amount of 1 unit. So this change is 3 units. So the unit of x is equal to 3 units. So 4 minus 1 equals 3 units. This is the change in x. So now we have the change in y, and we have the change in x. And the slope equals how many times y differs from x. And this is what we've talked about a lot. So if I take the change in y and divide it by the change in x, or this length along the vertical axis, and divide it by the length along the horizontal, in the horizontal direction, that number is the slope. And that tells me, or tells you, how many times you need this value of x to equal the number of units in y. So you need it, whatever the slope is, you need it that many times. All right, so we talked about this. The value of y is the slope the slope times the value of x. So the value of y is so many times different from the value of x. So y is the slope times x. And we're going to use numbers pretty soon, it'll be easier. And so y equals the slope times x. All right, so y is calculated as the change in y. So this length right here, going from here up to here in the vertical direction, that change is called the change in y. It's calculated as the change in y. And we know that now that is 6 units. And the x is calculated as the change in x. So to go from here in this direction, you end up here, but you're moving in the horizontal direction. That change in the horizontal direction is calculated as the change in x. So 9 minus 3 is 6. That's the change in y. And 4 minus 1, this 4, or this 4, same thing, minus this 1 is equal to 3. And that relationship is 6 divided by 3 is 2. And what that tells you is that the change in y is 2 times the change in x. So the change in y, 6 units, is 2 times this change in x, 3 units. So 2 times that 3 tells you that you need 2 of those 3's to equal 6. So the change in y is twice the amount of the change in x. So this is twice as long as this x value along here, along this axis. So the change in y is twice as much as the change in x. So you need 2 times this length, which is 3, to equal this length, which is 6. And up here, remember we were talking about the slope triangle. So all of this work was talking about the slope triangle. Now what if we remove the slope triangle and just talk about the points? So if we remove the slope triangle and just talk about these 2 points, what's the change in y? The change in y is 9 minus this 3 is equal to 6. And what's the change in x? It's this 4 right here minus this 1. So it's going to slide over this way. 4 minus 1 is 3. So you compare the two, the change in y, this length, going up and down, is 2 times longer than the change in x. So y is 2 times the change in x. So the change in y is 2 times the change in x. Now, we're not going to do this right now. I just want to show you where we're going. So eventually we're going to write equations. And the cool thing about this is you've already done this. We did this a while ago. And this is just going to be reminding you of how we did this. So we took, if we labeled this as x and this as y, so y minus 3. So this y right here minus that 3 compared to this x minus 1. So we did this a while ago. And what's that equal to? So this was the left side of the equation. The right side of the equation was the slope that we already had calculated using these 2 points, and that equaled 2. So now you have y minus 3 is 2 times greater than x minus 1. So the value of y, so this value up here, minus 3, is 2 times this value minus 1. So y minus 3 is 2 times the x minus 1. So you could write that as y minus 3 equals 2 times x minus 1, which use the distributive property, that's 2x's minus 2. So then you get this equation. If you subtracted this 3, you have to add the 3 back. So y is equal to 2x, and you have to subtract this 2. So you add 3, subtract 2, you end up with 1. And that would tell you that this y-intercept down here, which we just started talking about, or the vertical intercept, was equal to 1. Well, you use the slope of 2. You go out for each unit change in x, you go up 2 units for y. So go out 1 unit, go up 2 units, and look where you end up. You end up at this 0.3. That's a lot, what I just covered, and we're not going to do this right now. I'm just showing you the direction that we're going. And when we get there, it will make sense to you because you will have practiced these things a bit. All right, so B. So now we're going to reduce the drawings a little bit and just look at what's going on in a little bit again, I guess. So the change in y, so how much is this direction changing? It's changing 3.5 units minus 1.5 units. So this is going up how far? It's going up 2 units. This length is 2 units. And how do you figure that out? When you take the 3.5, this is 3.5 right here, and you subtract 1.5. So this is 1 5/10. In the vertical direction, this is the y value. Whoops. This is the y value at 1 5/10, so you subtract that away. So 3.5 minus that 1.5 tells you that this change in y is 2 units. The change in x is 8 units. So you're going to take this 10 and subtract these 2 units. So how far did you go out? You went out from this beginning point, which is right here. So you start at 2. Then how much further did you go to the right? You went 8 more units to the right. So how do you figure that out? Well, I ended up at 10. So I'm going to subtract these 2 units. So the horizontal change, or the change in the x direction right here, is 10 minus that 2 equals 8 units. So the x units in the change in x equals 10 minus 2 equals 8 units. The x units in the slope triangle. These number of units in the slope triangle. So what's the relationship between those two numbers? What's that tell you? So first of all, we talked about this a lot. So we're not doing this as much anymore, but you move the slope triangle down how far? Down 1.5 units, because you subtract this 1.5 units, and you move it over to the left how far? You move it over to the left these 2 units. So you move, it's like moving this point down 1.5 units and to the left 2 units. So what's the relationship? The relationship is the number of units. The change in y is 2 units compared to the change in x is 8 units. So that's 2 over 8 and it equals 1/4. So what that tells you is that this length in the vertical direction is only 1/4 the length in the horizontal direction. So this is shorter. It's 1/4 of this length. And if we look at it as the slope triangle, this is x and this is y. So this is stuff that we're going to get into once again, but just kind of a quick look at it. So y minus this 1.5, this is the left side of the equation, and x minus this 2, and we know that equals 1/4. That's the slope. So of the slope triangle, the units of y are 1/4 the x units. And the equation, you go through some algebra here, and you end up writing this equation that y is equal to 1/4 x. That's the slope right there, the 1/4. And what's this number? That's the vertical intercept, or the y-intercept. So this is 0, 1 right here. And the slope is 1/4. So you go out, actually it says 2 units here. You go out 2 units, you're going to end up going out 2 times 1/4. It's 1/2 of a unit. So you go out 2 units and 1/2 of a unit, and look where you end up. You end up at 1.5. So this is 1.5 right here. All right, again, the change in y compared to the change in x. The change in y, how much is this changing? You're starting at 35 and you're ending at 75. What's that change? 75 minus 35 equals 40 units in change. And you're starting at 10 and you're ending at 30. So what's that change? So 30 minus this 10 is 20 units. So this change is 20 units. This change is 40 units. So how many times larger, because it is larger, How many times larger is the change in the vertical direction compared to the change in the horizontal direction? Then you take this number 40, this change in the vertical direction, divide it by this number 20, the change in the horizontal direction, you get an answer of 2. So that tells you that it takes 2 of these lengths to equal 1 of these lengths. So the y length, the change in y, is 2 times the change in x. This is the old language. The y length is equal to 2 times the x length. But now we're going to change it. The change in y is equal to 2 times the change in x. So it's 2 of these lengths, which is the change in x, to equal 1 of these lengths, which is the change in y. And the equation, once again, and we're not going to do this for a while, but if you label this x and y, you guys now are starting to see this. Y minus 35, that's the change in y. X minus 10, that's the change in x. That relationship is the slope, and we already figured that out. That's equal to 2. So what you can say is that it takes 2 of these x values to equal y. So y minus 35 is 2 times greater than x minus 10. So y minus 35 is 2 times x minus 10. So y minus 35 equals 2 times x minus 10. Use the distributive property. If you have 2 x minus 10s, you have 2 x's. You have minus 10 2 times, minus 20. You have to add the 35 back, and you add 35, but you still have to subtract that 20. So 35 minus 20 is 15. So y is equal to 2x plus 15. So this y, or vertical intercept right here, is 15, and the slope is 2. So you go out 1 unit, and you go up, actually you go out 10 units, then you're going to go up 20 units because the slope is 2. So this length is twice as long as this length. So go out 10 units, go up 20 units, and 20 plus this beginning amount of 15 is actually equal to 35. So this stuff, what I just said, we're going to get to. Don't worry about it. I'm just showing you that you know how to do this before we ever even go through the next lesson. All right, so you put all that information into this table at the end. Now I switched the horizontal change and the column for the vertical change. They were written in the opposite. The horizontal change was over here, vertical change was over here, but I switched them because, as we have been doing all along, we've been putting the x values in the left column and the y values in the right column. And so once we figure out the slope, that's going to be how many times the vertical change is compared to the horizontal change. So then you just multiply this number by that slope to get this number. And we're going to do that in just a moment. So the vertical change compared to the horizontal change is 6 divided by 3 is equal to 2. That means that you need 2 of these 3 units to equal 6. So 6 is 2 times that 3. 2 is 1/4 of 8. So 2 divided by 8 is equal to 1/4. So this 2 is 1/4 the length of 8. And 40 is 2 times 20. So 40 divided by 20 is 2. So that 40, this 40 right here, is 2 times this 20. So 40 is equal to 2 times this 20. And so the slope is 2 here, the slope is 1/4 here, and the slope is 2 here. So go through that one more time. So that 6 is 2 times this 3. This is the vertical change. This is the horizontal change. The vertical change is twice as great, twice as big as the horizontal change. So that 6 is equal to 2 times this horizontal change, which equals the 6. 2 times 3 equals 6. So the vertical change is 2 times the horizontal change. Next one. This vertical change is 1/4 this horizontal change. So 2 is 1/4 of 8. So this vertical change is 1/4 times that 8. So 2 is equal to 1/4 times that 8, or 1/4 of 8. So the length in the vertical direction is just 1/4, so it's pretty short compared to the length in the horizontal direction, which is going to be 4 times longer. So this length is long. The length in the vertical direction is just 1/4 of this length in the horizontal direction. And the last one, the slope is 2, so that means the length in the vertical direction is going to be twice as long. So it's going to be pretty long compared to the length in the horizontal direction. So the length in the vertical direction is going to be twice this length in the horizontal direction. So 40 divided by 20 is 2. That tells you that 40 is 2 times this 20. So you need 2 of these 20s to equal that 40. So the change in the vertical direction is 2 times the change in the horizontal direction. So the change in the vertical direction, 20, is 2 times the change, the change in the vertical direction, 40, is 2 times the change in the vertical direction, which is 20. So 2 times that 20 equals 40. So the vertical change is 2 times the horizontal change. So this is 2, this is 1/4, and this is 2. All right, the last part of this activity is just to take letters and write the slope using these letters. And I want to remind you that this point right here, the horizontal length is u. It's the same as this u up here. So you're going out from the y-axis u units. So you're going out to u, and then how far are you going up along the y-axis? So this point right here is t. It's the same as that t right there. So you're going up here, t units, and you're going from here in this direction, u units. So what's the change in y? So it's this y value, which is v, and you have to subtract this amount right here, which is how much? Well, that is this t right here. So this is t units up, so you have to subtract that t. So v minus t is the change in y, v minus t, compared to the change in x. Well, how much did x change? You started out here at s, and then you went u units to the right. How much of a change is that? That is u minus s. U minus s is the change in x, and that's the slope, the comparison of these two changes, change in the vertical, change in y compared to the change in x, is equal to the slope. And I like the way I said that a moment ago. You started out at t, and then you moved up this number of units to get to v. So you have to subtract the amount that you started with. You started with t, and then you went up this many units to v. So this amount right here is this v minus the starting amount, t. All right, so you get used to this. It's okay. All right.